Okay, good morning, everyone. Welcome to the second edition of our February webinar series. My name is Kevin Nyangweso. I'm the sales manager at Keton Consulting Limited. Today, we are going to be having a discussion on third-party controls. How do we ensure reliability beyond the manufacturer kits? So we understand that manufacturer kits do come with their own quality controls, but as an additional check or an independent check, the standard ISO 15189-2022 advises on the use of third-party control. So today we want to understand what is a third-party control, when do we use third-party controls, and how do we differentiate what are manufacturer controls from third-party controls. And then we'll be able to understand how third-party controls are better or offer more insights when compared to the manufacturer control. So this is just going to guide us on how do we develop a risk-based strategy to evaluate our daily QC performances. So welcome to the presentation. Our presenter today is Ms. Catherine Gichuki. Catherine Gichuki is a seasoned quality manager implementing ISO 15189-2022. Currently, she's the QA manager at Nairobi West Hospital, where she's done exemplary work in terms of ISO implementation, risk management, internal audits, and all that line of QMS implementation. So I welcome you all. I hope I'm quite audible to the webinar. In between the presentation, you can use the chat box to just drop your questions. We will be able to see them, and at the end of the presentation, the presenter will be able to answer all your questions. So in the presentation, if you have any question that you need clarification, any point that is not clear, kindly be able to just drop a question in the chat box, and we'll be able to respond at the end of the presentation. If you have a question that you need to maybe speak, you'll just raise your hand and we'll be able to unmute your microphone, and then we'll be able to give you a chance to speak. So that is our introduction. Today I'm with Ayub. Haroun Ayub is the technical manager at Keton. So he oversees all the technical operations, including support to our end users. So I thank you for all joining us. And Catherine, I think maybe you can just take the microphone and proceed. Catherine, the microphone is yours. You can unmute and then you can start.
You can hear me now?
Yes, I can.
Okay, sorry for that.
It's okay.
So my name is Catherine Gichuki. Thank you so much, Kevin, for that introduction. I feel humbled to be your presenter this morning. I am currently serving as a quality assurance manager lab in the Nairobi West Hospital. And I am happy to be sharing this information with us as techs, as colleagues. And today we will be discussing about third-party controls in medical laboratories. He has done a very good introduction. And so I will go direct to the presentation today because we have so much to cover. And if we are able to, because we will be able to, we will see, and at the end of the day, the insights, we will, at the end of the presentation, the insights that we will be able to be informed about. So what are our objectives, or what do we want to gain at the end of this presentation? We want to be able to differentiate between manufacturers and third-party controls. We want to be able to map third-party QCs to the standard that we're currently using, which is 15189 2022 version. And we want to be able to do a risk-based design QC strategy using independent controls. And with time, we will be able to see which are the independent ones. And we will be able to see how to implement, monitor, and also provide governance across all sites if you're using many sites or platforms. And then briefly, maybe not into depth interpretation of QC data, that is shifts, trends, and biases, and how we drive our CAPAs. So what is quality control? Quality control, I'm not giving the technical definition, but I'm saying it's core. It's a core check within our QMS systems. It is a core check within our quality management systems. And this usually ensures validity of the results that we are examining. I mean, the results that we're producing after the examinations. So this is required because our modern labs face a lot of risks. And risks are the ones, if we start looking at risk at depth, we might even go into much depth, but the risks that we want to maybe try to envision is the risks that are even pertained to our operations. For example, reagent lot changes. We are changing lots of reagents every day. It's something that is inevitable. So that is a risk on its own. When the engineers are coming and they want to do an upgrade of our software, that is also a risk on its own. When we're doing maintenance, when you're doing maintenances, the variabilities that are coming out of that maintenance, daily maintenance, PPMs, the planned preventive maintenance are also risks. And then when we are doing harmonization across platforms, across multi-sites, that is also a risk on its own. Therefore, we need strengthened quality control systems. And by this, when we do this, we are able to gain reliable lab results, which are critical in decision making during a patient's journey. Because our role as lab techs, as medical lab technologists, is to be able to aid in clinical diagnosis, to aid in clinical decision making. So if we're able to produce reliable results, then of course we have checked the patient safety. So what are the types of QCs that we interact with every day? We have 4 main ones. There are many others, but these are the 4 main ones. Internal quality control, which these usually are daily checks to ensure analyzers, that the analyzers are working correctly. Then we have the EQAs, which I know is a very familiar term, the EQAs, the external quality controls. These usually are used to compare our results with other labs, the peer groups, we've heard of them. Then we have process QCs, or process quality control. These usually ensure correct procedures are followed. We follow the right procedures all the way from pre-analytical to post-analytical stages. For example, when you're checking the equipment maintenance checks, that is a process control. When you're checking temperature logs, that is a process control. When you're checking something like sample acceptance criteria, rejections, that is a process control. Then we have the other one, that is the post-analytical quality controls. Post-analytical quality controls are the checks that we do after analysis, after analysis, before results are released, where you want to verify whatever results you're producing, is it the correct thing? Or you want to be sure that that which you're producing is reviewed before release. For example, delta checks. People nowadays, systems nowadays have been aligned to do delta checks, where a system tells you that something is wrong before you release the results. So that is what you're calling post-analytical QCs. So now we will be dealing amongst the QCs now, what we will be dealing with maybe in depth is the internal quality controls. And we have said that internal quality controls checks or ensures that our analyzers are working correctly, our processes are correct, from all the way from pre to post on a daily basis. So internal quality controls can be subdivided into two: manufacturer's quality control and third-party quality controls. So the manufacturer's quality controls are supplied by the same company that has made the analyzer, has produced the reagents. That company also produces calibrators and controls. So those are the ones that we call manufacturer's quality controls, and they're used to check daily analyzer performances. But kindly note that they may not detect all analytical errors. We'll be seeing why and how they don't do that. So third-party controls, they are the controls that are supplied by somebody else, by another vendor other than the manufacturer, independent from the manufacturer. So usually they're used to independently verify trueness and accuracy of that result. And additionally, offer safety layer. We'll be seeing layering of QC. So they offer safety layers to verify our performances. We want to check out the differences between a manufacturer QC and a third-party QC. Manufacturer QCs are made by the same company. We have mentioned that they are made by the same company that is making the analyzer and the reagents. The third party, however, is made by an independent manufacturer or supplier. So the manufacturer QC usually confirms the system is running. Is it operational? That is why you find even during the installation, they come with the installation, the calibrators, and the QC. During calibrations, for example, for the hematology machines, they are calibrating and then checking whether it is aligning to it. And then the third parties will confirm the results are true. Will confirm the results are true and accurate. So the manufacturer's QCs are optimized. They are optimized for its own QC, specific for that QC. So it's optimized. And usually they may miss hidden biases, usually. The third party, on the other side, are better at detecting drifts, biases, and a lot of other issues. So the manufacturer's QCs are platform specific. Hardly will you, actually, it is not even advisable that you're moving one QC for a machine to run it on the other side. Usually it's not, but usually it's made for that specific platform. Then the third-party QCs on the other side are comparable across platforms and across other sites. Usually the QCs are good for routine daily QCs. On the other side, third-party QCs provide stronger audit and governance evidences. When you want to provide evidences in audits and governance, maybe in management reviews, or when you need evidences, that is where it really makes a point. Okay. Sorry for that. Regulatory and accreditation alignment. Like Kevin started by saying that we want to see how third-party QCs, or we have seen and we have had during the gap analysis and interpretations of 2022, how the ISO, or the standard that is governing or guiding us, tries to advocate for the use of third-party controls. So by this, the standard will require that during pre-examination, QCs are done to support verification of reagents and system readiness. So we need QCs must be used pre-examination to show accuracy in pre-examination, and during examinations, ongoing QCs to monitor analytical performances. Third-party QC will be able to go way and beyond to show any other bias or drifts or shifts or any misalignment with what is supposed to be is usually caught by this third-party QC. So during examinations, we are told, or we are advised to continue using QC on an ongoing way, and we'll be looking at the risks of and how we are able to make decisions when and at what time to do QCs. So then the standard expects us that we ensure validity of results, that when we are giving out results, we have ensured that the validity of those results. So the third-party QCs, in this case that we are calling them independent, or we are also calling them independent QCs, strengthens that assurance. And then we are able to control any occurrences that are out of the norm, any quality controls or any control that is out of the norm, the non-conformities, the QCs are able, or the third-party independent QCs are able to detect it early. Then we are expected by the ISO to improve. That is, we check on the trends analysis. And that way we are able to start start preventive actions before. Then during audits, the evidences that we produce, of course, the standard expects us to have all these, the QC policies, the validation records, the peer group reports, and trade charts and catalogs, and many other things that we are supposed to produce. So when we engage in third-party QCs, we are able to see all these come in them. The validation records, they are traceable to a certain matrix. They are traceable even to a higher defined standards, and we have a way that we are going to be looking into it, where we see the things that are required, that should and are produced during audit. Then limitations, we're going to look at the limitations of the QCs, and we will be looking at the limitations of, right now we're looking at the limitations of the manufacturer's controls. The first one is potential manufacturer bias. Controls usually, or these manufacturer controls are usually optimized. We mentioned about them being optimized to work with the vendor's own reagents and analyzers. So they are, in other words, have been enhanced to act nicely with its own reagents and its own analyzers. So it is biased. It has been optimized only to work with that. So usually it will not catch any other drift or shift. It is only monitoring that reagent and that analyzer. Then the second one is the system checking itself. For sure, when the manufacturer is making an analyzer, makes a reagents, makes a calibrator and a QC. To do what? To check itself. So this one usually can cause the QCs that is supposed to be a check of everything else that has been done to miss a hidden system-wide error. So a system-wide error will be missed if a QC, or we rely on a manufacturer's QC only. Usually, they have lower sensitivity to drifts and shifts. We have mentioned that because the subtle analytical shifts will go undetected. Those ones that usually are caught by the third party will go undetected. Limited cross-platform comparability. We say that they're specific for a platform. They are platform specific. So it is usually very difficult to compare results across different machines and sites. They have a weaker audit defensibility alone. So when you're just defending yourself with these QCs only, usually we can call it's a little weak, because the reliance on vendor QC only usually, or maybe questioned during audits and investigations. We also look at the limitations of third-party quality controls, and we can all agree that cost implications, because it is an additional cost compared to using only manufacturer QCs. That is why you usually hear that quality is expensive. But then again, we'll be looking and seeing how expensive is quality. Storage and stability requirements. For sure, they have very stringent requirements. They require strict cold chains and careful handling. And then method compatibility and verification. Usually the target values must be locally verified for each analyzer. When you configure your QCs and you're running them, you will run them, you'll run a number of, you'll make a number of runs and then be able to monitor whether there is a shift, whether there is a trend, and because not all controls are commutable for every method. But then again, it allows you to adapt your own lab or configure and adapt your own lab means and ranges. Training and workflow impact, of course, when you're introducing third-party QCs, you must, or it's always required for you to train the staff on the new QC materials and rules. Most definitely, because once a machine is installed, there's that bit of training, there's that bit of training, of course, training running all the way from maintenance to QCs. And then now, once you introduce a third party, there'll be this bit of you trying now to introduce a new process or a new procedure. Then staff have to be trained on the new QC rules and the materials and rules and all that. Then, of course, this is going also to increase our workload. There'll be that bit of configuration. People who have worked with that party, you know that there's that bit of preparation that before one QC ends and a new lot is coming in, you need to prepare for configuration, you need to prepare for lot-to-lot verification and all that. Then data management complexity, additional QC data to review and to review the trends. Of course, you'll have more. If you're doing the two of them together, you will have more to review. And then it also requires a very good way of analysis. For example, nowadays there are LISs and softwares that are supporting this kind of interpretations. We'll also be looking at the value propositions of third-party QCs, why we feel that they are valuable, the third-party QCs are valuable, not even we feel, why third-party QCs are valuable. The first one is independence, independent verification of assay performance. There is an external check that is usually done to confirm it working on a machine specifically. If you look at the inserts that come with the third-party QCs, every machine has its own ranges, the SD, the ranges, the target, specific for that machine. So an external check to confirm the machine is working correctly. So that way, because you're already assured that you're using specifically for that and that it can be able even to do for others. So we know that you're not checking, that you're not using a QC that it has been optimized to check itself. So it is independent from the rest. It is independent from any other biases. Then it is enhanced. It has been enhanced. It ensures enhanced detection of biases, drifts, lot-to-lot variability. Usually when you run that, but it helps spot small changes and errors early before they affect patient results. Another value is cross-platform comparability and harmonization. Like I've mentioned that we have different machines mentioned in it, and you can be able to compare yourself. It allows a fair comparison of results between different machines and branches. If you have more than one site, more than one satellite, you can be able to do comparison. Then stronger audit defensibility and governance confidence. It makes it easier to explain and defend your Qs, the quality control system to auditors and even management when there's need for evidences. Then it supports multi-site quality standardization. Usually when you have more than one branches, it helps all the branches follow the same quality standard and perform consistently. Why third-party controls are reliable. Remember, we mentioned that they are reliable. They have been made in patient-like material. They are made to behave like real patient samples. They have been made, yes, to behave like real patient samples. Then the peer group target values. We have target ranges based on results from many labs. We can be able to do this, we can be able to achieve this. So traceable values where applicable, linked to reference methods or standards when available. Usually they are linked to reference methods and standards, like I mentioned, and they're stable and consistent over time. Those that I've used or those that have been privileged to use third-party QCs, you can see that usually lots run even up to even 1 year, even 6 months. And that stability or reliable across lots, you can be able to use them over a long period. If you preserve them, like we mentioned, they have stringent ways of preservations and handling. If you meet whatever you have been told to do, you can even be able to use them over long use. They don't deteriorate that fast. Then checked during method validations. When they're being manufactured, there's that confirmation that this over time, if you hear or if you get to listen how they are made, they use usually that way of validating these QCs before they are released and their values put in inserts. So if you're using, for example, alinity, you're using, for example, Cobas, you can be able to see that there are values for Cobas, there are values for alinity, there are values for Snipe, there are values for all those machines that we have been privy to use. So that party QCs have been validated for those methods specifically. So when we look at QCs, designing them on a risk-based platform, as QC officers, because I want us to look at this as QC officers, all of us are QC officers. We are champions of QCs in our own way. And wherever you've been assigned or whatever you've been assigned to do, of course, you check your competences and the competences of and the reliability of everything that you're using the QC. So that is where you're a quality officer on your own. So when we look at how you make decisions and how to design your QCs, we will be looking at it in a risk-based manner. So first of all, you're expected to identify high-risk assays. High-risk assays, for example, are like you look at the critical values, you look at the high volumes, exactly. You look at the high volumes and then the unstable reagents. There are those unstable reagents that you notice. Maybe when you look at the trend, after 2-3 runs, it starts to dip. So they are very unstable. For example, in a certain platform, you can find maybe 15.3 is a little unstable or usually unstable. So you will be able to see that this is a high risk assay. The QCs, for example, for electrolytes, you notice that after several runs, there's usually a dip or there is usually a bias or a shift. So when you identify a high risk assay, so that is the first way to do it. Then once you define it, you identify, then you define QC frequency by a risk tier. You want to identify, for example, you can decide that now that QC, now that our ICT module is unstable after how many runs, then we will be doing it after every shift or per shift, or we'll be doing 15.3 on a daily basis as opposed to doing it maybe once a week. So that is how you define QC frequency by risk tiers. And then you layer QCs. Remember, we mentioned about layering QCs. This is where you use a manufacturer's QC operation to check the operations. And then you want to layer it with a third-party QC, which is independent and gives you an independent assurance. Then these trigger points or whatever is you want to check at recheck or any major change, when you want to do, when should you recheck after any major change, or when do you need to do these QCs? Usually Always run QCs after reagent lot changes, after software updates, after maintenances, after method changes. The higher the risk of a test, the more often and the more independently we should check it. So we will also be looking at the implementation framework. If you'd want to implement the third-party QCs, there's a step-by-step way. The first one is usually to select. So a practical step-by-step plan. The first one is usually to select, where you choose commutable or third-party controls compatible with platforms. You want to check what works for the platforms that you're using in that particular time. Then you check the verifications, or rather you verify. That is, you establish lab-specific means and CVs and SDs are usually done after an adequate run. A number of runs, we'll be looking at it. Then you want to define the rules, the Westguard rules or the multi-rules, strategy rules that are appropriate to that platform or to that third-party QC or that analyte. Then there will be the update of QC SOPs. If you already have SOPs, you want to update the QC SOPs and also mention the acceptance criteria. Of course, you will be doing training. You need to have staffs that are trained, competency-based trained. Then you roll out. First, implementation across sites. You don't want to introduce it all through. You can decide maybe we are doing this, maybe if you have two platforms, you're doing it here, monitor how it's going to be performing. And after you monitor how it's going to be performing on this platform, maybe introduce it to the next one, or even you can go in profile-wise. So this is about that party QC into a controlled, standardized process. You just do not want to do it as an ad hoc activity because it is a core activity. So you want it controlled and standardized. So we can have a roadmap of maybe 90 days. You can do it however way you want to, but maybe this is just a roadmap of 90 days, how we are supposed to do it. And it's a practical way, a 3 months, 90 days, 3 months practical plan that we can use to roll out our third-party QCs in a structured way, instead of just doing it all or everything at once. So the first month, you're advised to start the preparation, selection, SOP updates, staff training. So you choose the suitable third-party QCs, you update your SOPs, you train. What you want to get out of this is a good foundation, a right, correct, good foundation, because this is the planning phase. Then you test and refine, that is verification, rule setting, pilot in high-risk assets. You want to see how it's performing, then checking the trends and analysis, the LJs, checking on anything that needs to be verified. And then usually when you do this, you want to ensure that whatever you have rolled or whatever it's working well before you roll it out. You want to ensure before you say that you usually use this, but that particular QCs, you want to ensure that the correct thing has been done. And now the networking. You network, rollouts, dashboards, KPIs, governance, everything to work together. So you, for example, roll out across all sections and sites. You have tried this section and it's working. You have tried this platform and it's working. So you roll it out as you set the QC dashboards. You agree on regular governance reviews. You agree on how often you're going to do according to the risk-based QCs designs that we have seen. Then you make QC sustainable and well governed across the networks because you have followed that channel. You're first selecting, doing SOPs, the preliminaries preparation. Then you're doing the verification and then you're rolling out. And then at the point of rolling out, now you want to be monitoring your QC, the KPIs, the governance cadence and everything else. So you start small, you validate first, then you scale with governance over those 90 days. And then from then you'll be able to roll out. So when you need data governance and documentation, the things that you need to have as documentation, because remember in QC, what is not documented, of course, is not done. So it's a must that you have a QC master file where you have your lot numbers, your expiries, your storage conditions, everything talking about the procedures that are expected for that particular QC. So you keep the records of all QC materials. So this is about record keeping. Everything, how to store, the expiries. So you can be able to trace any QC issue back to its specific lot. For example, you can introduce, or it's advisable to introduce a preparation log, QC preparation log. Usually, most of the third-party QCs will come lyophilized. Of course, there are options of those ones that are coming ready. And even for those for ready to use, once you open, you're expected to note in what day you opened, what time you reconstituted, how many mLs of distilled water did you use, or the ionized water did you use, the day that you prepared, who made it. So it is traceable back to that particular QC. So then you do method verification records for each platform. So you will have to document each QC material works correctly. That's even before you start using, before any routine use, you want to document it correctly. Then you will have peer group enrollment and performance reports. This one usually allows us to keep reports showing how our QC compares with other labs using similar methods. You can be able to do that even with EQAs or PTs, anything that can be able to compare us with other labs using similar methods. Then you documentation and also governance of trends and charts, trend charts, that is LJs, shifts, biases, and logs. To maintain, you have to maintain the performance and to be able to be at point or to be able to be in control of QCs, you have to maintain an LJ chart and logs. And these are not monitored at the end of the month. An LJ is monitored on a daily basis. Reviews of QC should be on a daily basis. So you can be able to catch any shifts and trends as early as possible. And where there are non-conformities or where there is an excursion, you can be able, or you will, or you have to keep records of corrective action and preventive actions. So CAPA records have to be kept linked to any QC non-conformities, excursions. So you will have to document what went wrong. If something goes wrong, what went wrong when this QC failed? What does it, or what was done to fix it? And how are we planning to prevent any recurrence? So good QC is not just about running QCs. It's about documenting, you check the trend, the trending, and acting on the data. You just don't look at an LJ and notice, hey, it's going up. There's a positive bias, and just keep quiet. You want to act on it. So that is how you equate good QCs. So statistical QC and interpretations. Usually this is how we use numbers and rules, if I can say that, numbers and rules to make decisions whether this QC is acceptable and whether patient results can be released, because you need to make a decision. Remember, we are helping in clinical decision making. You need to make a decision before you misinterpret and mislead everybody else. So you set your own normal range. You run the QC many times, at least 20 runs, and then calculate your own labs average. Remember, we talked about adapting your own mean. It's acceptable. So you run at least 20 times, and then you calculate usually some platforms will calculate it for you, and then acceptable, if you find acceptable as this, this is what is normal for your lab, because usually they come with a manufacturer's range, but it's usually written, or even if you read the inserts and the documentation that come with it, is you are allowed or you are expected to do your own establishment of your own mean. So this is usually done after the 20 runs. Then you use QC rules to judge passes or fails. Apply very simple Westgard rules that match how stable the test is to decide when QC is acceptable or not. There is Westgard rules. There is a 1, 2S, all those. Maybe in another platform you'll be able to look at it, but you use your QC rules to make that judgment. Then you watch for different types of errors. Random errors. I know most of us have talked about random errors, systemic errors, shifts and trends. So you're going to watch, you're expected to watch out for that. So because results will jump up and down unpredictably. That is a random error that shows the imprecision. Jumping unpredictably, you can't, sometimes you run a QC, it fails, you rerun, it passes. What does that even, of course it raises an alarm. So usually we cluster that as a random error. Then we have the systemic errors, usually biases. Results slowly move up or down. It's systematic. It's going either up or down. There's just a bias that is happening. Then you have the shifts and trends, sudden or gradual changes over time. At once, over time, that you have the sudden or gradual change, mostly sudden. And now after that, you know when to stop and escalate. You define clear limits for when to stop releasing patient results and escalate to seniors for investigations. Maybe you want to escalate to the section, to the supervisors. You want to escalate to the QA manager, like that. Then, so usually the statistical QC, that bit of the statistical quality control helps us to make a decision. And you make these decisions not by your own mind, but you're guided by data and rules. When results are safe to release and when to stop and do investigations, because usually what the ISO has advised is you stop, especially for the EQA. You stop, make a correct, and even go back. After stopping, you just don't stop and then correct and move on. You go back. It advises that you go back, check a few samples, and even recall those that you are able to. Peer group comparisons and interlab harmonization. We want to compare our lab QC's performance with other labs. We want that when somebody comes to the Nairobi West Hospital, does, as for example, thyroids, and they go to Mata or they go to Karen, that there's not that variation that somebody is receiving treatment here and the other place they're being told that you're okay. So we want to compare our lab QC performance with other labs and using that information even to make results, to make results more consistent across branches and machines. If you look at the standard, there's a lot of, we've talked about comparability. So you're able to do that even when you have two platforms in the same lab, that this compares to this other one. So we are going to do this by benchmarking against other labs. So we use third-party QC peer reports to see how our results compare with similar labs and that are using the same methods. Then we spot outliers early. It helps us to spot outliers early. This one I don't know, I can insist how I can insist, but usually you identify when the lab or specific analyzers is performing far above and below the peer average. You can be able to see these signals. It appears as a signal, and it signals you to identify a possible problem. You'll be able to see that if you can, for example, you're reviewing results and you notice all sodiums are giving a 130, a 131, a 132, all low, but at 130 is hapo. When you go back to the LJ, if you had not checked which is your advisable before you start reviewing, you want to see how the LJs are. If you go back, it's going to show you a signal that clearly even the QC is reading at a low. So it's able to signal a possible problem. So then you make results consistent across sites. Comparison aligns performance between branches and different instruments, like I have mentioned. So patients get comparable results everywhere. So that is what we achieve by using third-party QCs. Provide governance evidence. Peer group reports, like we have said, serve as proof to management and auditors. When an auditor is coming to your lab, when you're saying that you're comparing your results, you're having a peer group reports comparisons. Of course, you will have very good evidence based. What is it called? The audits evidences that you're on top of the game. Your QC system is on top of the game, and the lab network is monitored and harmonized. You have evidences to show that. So peer group comparison helps ensure every result are not just internally consistent. That is what I can say. That when we do peer group comparison, we are ensuring that it is just not internally consistent, but it is also aligned to our peers, to other labs. Usually when you're running QC, they are usually, we are bound to fail. Sometimes we find QC failures, or sometimes they are there, the QC failures. So what do we do step by step when QCs fail? Because what we are doing is to protect our patients and preventing the problem from happening again. We are protecting them and then preventing it from recurring. So immediately we are supposed to contain. We are supposed to hold results where indicated. If QCs fail, then we are advised to stop releasing patient results, because that is an implication that if I am getting a low, my patients are also getting a low. So until the issue has been understood and fixed, you're advised to hold. Then you do, after you hold now, you do that, don't hold and keep the results there. You want to do a root cause analysis as ASAP, just that time. You want to find the real cause. What is causing? What is the common cause? Is it a reagent issue? Is it a calibration problem? Is it a maintenance issue? Is it an environmental factor? E.g., for example, temperature? Is it an operator error? So you want to check what is the real cause. Then you want to fix that problem, the corrective action. You want to fix the problem by you taking an immediate action, such as, for example, recalibration, changing of results, of reagent, reagent replacement. Then you want to maybe service intervention, environmental factors. You're going to check whether you want to correct. If it was an environmental factor, maybe the AC was off or is not functional, and the temperatures are way too high and it's affecting. So you want to correct that, or you want to call for service interventions, service support, all that. Then you're expected to give or make an action to prevent recurrence. Usually, it's supposed to be a long term. When you're doing SOP updates, if you find the root cause was maybe something that you were doing wrong, and that's something that needs to be updated in the SOP, you do an update. Then frequency adjustments and training. For example, like I had mentioned, maybe you notice that this is a high risk test. Maybe you need to be doing it often. Maybe you notice that every time after calibrating of the ICT, after 6 hours, the results starts to deteriorate. So what is needed is recalibration. So you make a decision that the frequency of calibrating ICT will be per shift, or per every 12 hours, or by however the shift is. Then that is what we're calling about. We are calling frequency adjustment, and then training. That is just to ensure that the same problem does not happen again. Then we check on the effectiveness and management review input. Confirm if it worked and report to management. For example, you verify QC is backed in control and fit the issue, and actions into management review for an oversight, for a discussion. For example, you want to discuss it maybe during the CQI meetings or during your meetings, your weekly meetings, and say that this is what you have decided. You have decided to adjust the SOP. You have decided to make a frequency adjustment. Then maintenance and change management, post-maintenance and change management, checks must be done after any change to the analyzers and reagents before releasing patient results. That one we had mentioned, that it is mandatory. Always run third-party QCs after major changes. That is, maybe, for example, after PPMs, after repairs, maybe, or after we had mentioned software upgrades. We want to ensure that you're running QCs, and then you release only results when QC is acceptable. Only when it's acceptable. You clearly define and document the criteria for when patients' results can be released again. Then you document the authorization to release results. You record who reviewed the results. Who reviewed the results? They need to record themselves. Who approved the release? All that, the time and all that. So that is the documentation of release authorization criteria. Multi-site governance model. And this we had mentioned about the multi-site governance. And this is how to maybe manage quality control across multiple labs or branches or platforms. So once central QC policy have been set, it is applied locally. It is applied everywhere. So you have one standardized QC policy for all sites, but each site verifies and implements its own analyzers. You have to verify and implement your own verification in your own analyzers. Then same QC rules and escalation everywhere, because you're having a multi-site, but then that doesn't mean that everybody comes up with their own rules. You use the same QC acceptance rules and escalation processes. And then one network QC dashboard where you're using interpretation, where somebody else can be able to track your QC indicators, the KPIs for all sites in one dashboard to allow central oversight and early detection of problems. So that is about the network dashboard for QC or quality control KPIs, periodic inter-site QC review meetings. You should hold periodic meetings with QC, with your colleagues, the QC, the QA, the management, to compare sites, comparisons for sites like we had mentioned. So usually multi-site governance ensures that all branches follow the same rules, the same QC policy, the same QC standard and rules, central sites, local accountability, all of them together. Sorry. So we mentioned about QCs being or having an implication for cost. But remember, we mentioned that we will be looking at the cost base and risk justification, because you might look at it at that, but then it's helping us even salvage even more money at the end. So the direct cost, that is usually the money spent on QC materials and peer comparison programs. That is a direct cost. Then cost. Then we have costs that you are avoiding. You're avoiding repeats. When you do a QC, that particular QC, and you're sure of what you're doing, you avoid repeats, you avoid recalls, where you're recalling back results, you avoid complaints and reworking. Not when the doctor is calling you to ask about your QCs, you're also helping them to doubt yourself. No, you're supposed to be sure of what you're releasing. So you don't want to repeat every run, every question, every recall, or every question that somebody is questioning, you're also rerunning. So that one is also a cost that you're reducing. Then you're reducing the risks, and chances of patient safety incidences are usually go down, and you find very little negative audit feedbacks. Then governance value, defensible quality assurance, where you're providing strong and defensible evidences that the lab has a robust way of just assuring quality in their system. So the cost is of that particular QC, which in this case is a strong QC, is far lower than the cost of errors and recalls and patient harms and patient safety and all those audits, all those things that you're doing. So it is way far lower than that. So common pitfalls that usually we fall into, these are the common mistakes that labs make with QCs, and shows simple actions to prevent them from recurring. So not setting your own inadequate verification of target values. This is just not setting your own QC target. You're usually advised to, because if you rely on the manufacturer targets, like I have said, QC, those, they can be misleading. So what you usually do is to locally verify your own lab QCs. I mean, your own lab means limit the standard, the targets, and then adapt them. The other mistake is using QC rules that are too loose, a range that is too huge. Because if even a manufacturer's range, you'll find that some of them come with quite a huge range. But when you do your own adoption, you find that it becomes stringent. So usually very wide QC limits will not catch errors. You will be thinking umepita, everything is okay, but it is not catching error. So what you should do is adjusting QC rules based on how stable or unstable a test is. The ASI sigma, how is it behaving? That's how you S, and that is how you're supposed to. Then poor documentation or inconsistent documentation using, when you miss QC records, of course, even the audits or investigations become weakened. So what should you do? You should standardize or try to make documentation standardized. You document or record every QC across everywhere. What needs to be written needs to be written, what needs to be documented needs to be documented. Because even in the events of audits, you can't tell me that you usually do it. I can't see. It needs to be seen. When somebody comes doubting your results, it needs to be seen. You need to defend yourself, not with words, but with facts. So another mistake is reviewing QC too infrequently. You're reviewing once a month. I said QC should be reviewed on every run. LJ, every run. Problems can go unnoticed. If you don't, you'll notice, oh, there was a shift on this day, and that is the end of the month. On the 6th, today is when? On the 12th of February, there was a dip, and we have been dipping, and we have been there for a long time. So if you check them consistently, you'll be able to notice, oh, what happened? Oh, we changed our reagent. Oh, it's a new lot. So how was the lot to lot? Did it compare? Oh, for example, we say there was a ppm yesterday, or there was a ppm today. And after running the QC, there's a dip, so something is not right. So once it should be checked immediately, you check immediately, and then you set standards for that. Because good QC fails when it's poorly verified or just loose that you can do anything anytime. You need to have a proper documentation, and you review closely with each sample. Don't say that. It's not just running and saying zimepita, hakuna alarm, hakuna flag. No, you check on how it's performing. Then audit readiness and checks, of course, you say that it is used by the auditors on what the auditors will expect to see as evidences is QC policy and SOP approved, of course. You have to have these ones approved and trained. There's nothing that you'll be telling an auditor that you're doing and it is not documented. Then the verification records available. You have to show verification of your QC materials. Verification is this that you're saying that you want to check after the 20 runs. What did you do? You say we adapted a mean. Have records for that. Peer group participation, EQAs, where you're showing that you're proving that your lab participates in peer comparisons and all that. Then you're doing trends analysis and kappa logs. You keep your QC charts, trend reviews, investigations of whatever happened, the kappas. How did you go about it to prevent occurrences in the future? Then management review meetings, conference, referencing QC performances. When you're doing MRMs, either however the frequency that you have set, you want to see the QC performances. Actually, the management is usually very interested to see. So being audit ready, you have to have all these clear documentation and records and trend reviews. See, when the auditor is coming, is one who is identifying a shift that happened 2 months ago, and you've been going on very well. There's usually something, an expectation for the quality officers or because I called ourselves quality officers, is percentage QC runs within limits. What was within limits? The number of QCs related non-conformities. What did you do? The mean time to detect analytical drift. Check daily. You'll be able to catch the corrective action, preventive action, closure cycle times, and the intersite biases versus peer group mean. So what are our take-home messages? Independence strengthens trust in results. Using independent or third-party QCs, if you're calling them, will increase, of course, the confidence that the results you're producing are truly correct. So the other one is third-party QC enhances detection of hidden biases. And like we have mentioned, it will help detect subtle biases, those biases and errors that are just being missed by the manufacturer's QC. It's going to catch. The governance, documentation, and data interpretations are very critical. QC is effective only if you document it properly. If you document properly, then you're reviewing properly, correcting the interpretations, making decisions at the right time. That is only when QC becomes good. And then we've talked also, we want to take home layered QC, which is a best practice for accredited labs. Using both the QC, manufacturer's QCs, and third-party QC together is recommended, is something or a recommended approach, yes, for all labs. So strong QC needs independence. We need independence to be able to identify this as a strong QC system. It needs independence, good governance, and a layered approach to protect our patients, because at the end of the day, it's all about the patients. It's all about good clinical practices and making the right decisions. Thank you. So that is the presentation as of now. Whoa, we are way into the hour. So that is the presentation for third-party QCs.
Thank you so much, Catherine. That was a very intriguing presentation. You've given us so much deep insights. I think everyone is up. You can see from the claps, and everyone was quite attentive all through. There are a lot of questions, but before we take the questions, allow me to present something
Okay.
so that I can also so that we can just take the questions one by one. Mine is from a Keton's perspective. What do we have in terms of third-party controls? What do we offer as a company? So from the third-party controls, we offer value-added support, whereby when you buy quality controls from us, we give you free software tools to do your QC management, peer group, IQC comparison, just to see how your lab is performing in terms of QC vis-a-vis the other labs. You can do benchmark comparison, and also you can do internal documentation in terms of LJ review, if you want to do uncertainty of measurement, if you want to review your CV over time. So that is what Keton now comes in for you. I hope you can see my screen. So this is a sample of a quality control report that is done from Audit Microcontrols. With Audit Microcontrols, we get samples for clinical chemistry. We give you assay samples. When I talk of assay samples, I mean you get samples from us that is having values maybe for Roche, C111, SNIPE bioassays 40, majorly for chemistry. So if you want to do linearity samples, calibration verification samples, quality control samples, you can always get them from us. And this is a sample of a report that you get from us that gives you an LJ of the data that you've entered over time. And just allow me to show you something as we continue, now that I have got a lot of screens to present. I don't know if my screen is still visible if I share this. Okay, just allow me to present this PowerPoint, and then once I finish, I'll be able to show you everything. So in terms of hematology, what do we have? We have got hematology controls from Biotechne that is a third-party control, and also a linearity samples or a calibration verification sample for all these analyzers that you can see in my screen. That is Mindray, Zibio, Sysmex, Genrui, Abacus, Abbott, Beckman Coulter, Derui, Eden, Demand, HemoQ, Orphe, Reito, Urit. So all these machines that you have in your lab, we can give you hematology third-party controls that you can be able to verify your performance against the manufacturer reagents. You see, like the presenter has mentioned, when you use manufacturer QC against the manufacturer reagent, there could be an aspect of bias. But now if you get these controls from us, you get that third eye that is for you. So this is the for hematology samples, and then for chemistry samples, like I've mentioned, we get them from Audit USA. Audit gives us calibrators, QC, and linearity samples that allows you to verify your calibration verification, also linearity samples. So we have got samples for chemistry, amino acid, dimers, special proteins, tumor markers and hormones, urinalysis, proBNP, cardiac markers, PCT, therapeutic drug monitoring, and glycated hemoglobin 1C. So all these samples, you can get them from us as a third-party control. And then we also have third-party controls for urinalysis. If you're using quantitative or qualitative or semi-quantitative, you can get samples for third-party controls from us. We have got Quantimetrics from Clinica USA that you can use just to verify your dipstick performance for urine analysis. And then for molecular samples, we also have got samples from Zeptometrics from USA, which can be able to assist you in reviewing panels like monkeypox, HIV, respiratory viruses, that is RSV, SARS, and flu. And then we also have got samples for influenza, chlamydia, gastrointestinal panel, chikungunya, and vaginal samples. And then also for samples like torches, that is toxoplasma, rubella, chlamydia, cytoplasma, sorry. And then herpes, you can get samples from us. I meant cytomegalovirus, sorry. And then for HIV, syphilis, Lyme, malaria, Chagas, all these samples, if you're doing them in your lab, you can get third-party controls that can build support you over time. I wanted to share another screen before we go to the questions. So, like I've mentioned, this is a product catalog for the hematology products that we have. We have got controls, calibrators, linearity materials, urine cytology, and CBC controls. So, for example, from this one, if you have got different machines, so we have got products for Abbott, Horiba, Beckman Coulter, Siemens, Sysmex, Mindray, Diamond, urine cytology, flow cytometry, and linearity kits. So with these samples, you can be able to independently verify your analyzer performance, the reagents that the manufacturer has given you, without using the manufacturer controls that could be maybe biased towards their reagents. And then for audit microcontrols that I've also mentioned, this is like our product catalog that gives you linearity samples, calibration verification samples, and quality control samples. So for audit microcontrols, we have got assay values that come. So I wanted to show you something. I think I'm having a challenge here, but just in a minute. Yes. So this is like our kit insert. So when this kit inserts comes to you, it comes in this format. We have got, for example, this is an assay control for clinical chemistry level 2. So for clinical chemistry level 2, we have got audit microcontrols. You get vials of samples that you can reconstitute with 5 ml of distilled water or deionized water. And then like the presenter mentioned, you'll get an insert like this that comes with assays for different instruments. So if you have got Abbott Alinity or just Abbott, you'll get the ranges or the reference ranges here. And then if you have got Roche, then you also get the reference ranges for Roche. If you have got Biolis, if you have got Siemens, if you have got Roche Integra, Orthovitros, Beckman Olympus. So we have got assay controls for different analyzers. If I go to the hematology controls that I mentioned, we also have got assays for different machines. For example, if you're using Zybio, this is the assay values for Zybio. So we have got different assay values for Beckman Coulter. If you're using Sysmex XN series, if you're using Minray series, or even the Genrui series. So we have got different assay controls for different machines. And then in terms of immunoassays, we have got the Fortress quality controls that has got assays for different programs. For example, if you look at this, we have got assays for antioxidants, aqueous standards, blood gas and electrolytes, blood grouping, bone markers, cardiac, clinical chemistry. All these are available with Fortress Diagnostics. So if you're looking into procuring a third-party control just to have an independent view, we are able to support you just to have everything that you need for your lab verification and performance. So you can always contact us at sales@ketonconsulting.com. I think that is my presentation. It's supposed to be that brief. So I'll go back to the questions that we have within the chat box, and we'll go through them one by one. The first question that was asked by Jay Mbataru, he said, how frequent should one run a third-party QC? I'll try to answer, but I'll also allow the presenter to indulge. The frequency of running a third-party QC depends with the policy that you have as a lab. What does your SOP on running of controls say? So if you're running your controls maybe once every day, 2 levels once every day, 1 level interchangeably daily, once after every 2 days. So that policy stands with running of independent third-party QCs. So if your policy says you run 2 levels every day, do that. If your policy says you run 1 level interchangeably daily, you do that. If your policy says you run 1 level a week and you change every week, you just do that. So the policy of running your internal QC, whether you're using manufacturer QC or third-party QC, the policy stands. Is it the same? Do you share the same opinion, Catherine?
Yes, remember we mentioned about the risk-based QC design. You are the one to make the decision. For example, if I have an amino acid that I'm running maybe 5 or 10 tests a week, I can be doing QCs every day, because clearly the third-party QCs or even the manufacturer QCs, whatever the third-party QCs that you're using, reagents itaisha na QC. So you want to make a decision on the risk-based. But then again, you want to also analyze and see that this, and I can be having a reagent or a test or analyze that I'm doing once a week or once in every, or 10 in a week. So you can define and say, this is a risk-based. If, for example, a test, for example, like the ICT, you're doing so many of the electrolytes, you're doing so many of them in a day. You want to see that after you're the one to do an analysis and check that I can be doing it daily. I am safe, but am I that safe? But am I that safe? Is the patient that safe? So it is you to do an analysis, risk-based analysis. to make a decision. Then, like Kevin has mentioned, you document it, put it in policy, put it in the policy or the SOP that is guiding you, and follow with it. But that is not cast on a stone. You're allowed to keep checking. Is it making sense? There are even some assets that you decide on every run a QC because of the air instability.
Yes.
That's it.
So Mr. Mbataru, it's upon you to come up with a policy. It's upon you to develop the SOP on that guides running of internal quality control. So whether you're using manufacturer or using third-party controls, that policy guides you, okay? So Mr. Paul asked, do we have anything like back-to-back QCs? That is, running a sample today and repeat it the following day with 2 SD results. I didn't get him clearly, but do we have anything like back-to-back QCs? From what I think, like the previous questions, back-to-back QCs, it's upon you to decide when do you do your QCs. If you have one sample a week, why would you do QCs every day? If you have one sample after every 2 weeks, why would you do QCs every day? So you have to develop the policy that suits your own lab. Like if you're doing, for instance, you're doing toxoplasma once a week, why would you do that QC every day? So you have to develop a QC policy that guides or that governs that only suits your lab. So you can only run QCs in the frequency that you determine. And when an auditor comes, he will assess you against the policy that you have. So remember, an auditor will not assess you against an external policy. An auditor will assess you against the policy that you've put for your lab. So if you say that I'm going to do QCs every day, as an auditor, I'll ask you, just show me evidence that you did QCs every day. So if your policy says I'm going to do 1 QC a week, I'll ask you, just show me evidence that you did 1 QC a week. So develop a policy that suits your lab. I think that is clear. Samuel Asendi, you asked, one of the major issues I face with third-party QCs is commutability between different platforms. One platform gives different values from another. For example, you can find TSH values from the same QC material giving different values and have been assigned different reference ranges. When doing method comparison between these two platforms using third-party QCs, the total allowable error is quite significant. How can this variation in commutability be reduced? And how do you justify the discrepancy in TEA? Well, I'll try to answer this, and then I'll also allow Catherine to indulge. You see, third-party controls come with reference ranges for different methods. If you're doing clear or e-clear for Roche, it will come with its own reference ranges. And then if you're using alpha maybe for mini-vidas, it also comes with its own reference ranges. So if the two systems are not comparing, I think I would refer you back to the reference ranges for the individual methods. So unless you're doing method comparison using patient samples, and also patient samples, the reference ranges for one method would also not be the same for the reference ranges with another method. So I would advise you that if you're trying to analyze commutability and method comparison for the two methods, I would advise you that you use the same method. Maybe if you're using E-clear, that is Roche E411 against Roche E402, maybe Cobas pure. But commutability within different methods or different platforms is still a challenge that we really can't compare analytes on different methods and say that we would expect the same results. Different methods have got different principles, and also I would expect that the reference ranges for the different methods are specified differently. What do you think, Catherine?
Am I audible?
Yes.
Yes, I would reiterate the same, because usually, especially for immunoassays, most of the immunoassays have different methods. They're method dependent. different platforms use different antibodies, different traceability chains, different signal systems. So even the same QC vial, you will get systematic biases between platforms, especially for the amino acids. It's quite tricky. It's not just a QC problem. It's about method harmonization problem, because some third-party QCs, you'll find they're commutable, but not perfectly commutable, especially like I'm insisting for amino acids. So the QC matrices will interact differently with different antibody systems. So because remember, this is a matrix. It is a certain fluid or a certain media that has been packed with analytes. So it is going to behave differently, if I can say. So usually that is why you find even the third-party QCs have different means for different platforms, different SDs, even different reference ranges. And of course, the total allowable errors, of course, are apparent to, they tend not to compare. They are very discrepant, very different from one another, because I think that is how it is, especially for the third-party QCs. And maybe to reduce the commutability, like he has mentioned, the variation is maybe to choose a most commutable QC available. Just try and check how commutable. You can ask the vendor for commutability data by platform, that is, by platform. For example, amino acids like you mentioned, TSH, thyroids, you can check for commutability data by platform from the vendors. Then this one will help avoid the overly processed or synthetic matrices. I think that is maybe what I can say. Maybe you can do platform-specific mean settings, because you cannot force the same target. It can't be. It can't be. So that's it.
Yeah, and somewhere like Catherine has mentioned, when you get a new QC vial, you'll do your own QC verification and develop your own internal mean. So, like she mentioned, you can run the QC vial, maybe within day or between day 20 runs, develop your own mean, your own CV, your own SD, and then you compare it against what the manufacturer has given you. And then from there, you can just choose your own internally lab developed mean against the manufacturer specified mean or the manufacturer specified SD or CV. Kibet has asked, kindly guide on EQA lot to lot, the frequency, how and when it should be done. So Kibet, most of the EQA samples, we don't do lot to lot per se, because different EQA samples comes with different target values or peer values. So you can't do EQA lot to lot. I think what you need to compare is, if you're doing monthly equivalence or quarterly equivalence, you can only compare your Z score against different EQA cycles. If you want to do lot to lot, maybe if you mentioned IQC, what you do is internal IQC verification. When you get a new IQC lot, you run that IQC vial, the new IQC vials, I think at least 5 days before the older lot expires. You run it 5 days, you get your own lab developed mean, your own lab developed SD that you can use as the mean and the SD for the subsequent runs. So you can only do IQC lot verification, but not EQA lot verification. You just run it 5 times or 20 times, depends on what policy you have for your lab, and then you develop your mean and your SD. Catherine, you can also respond to the same.
You can hear me?
Yes.
Okay. So I can also say, because strictly speaking, EQA providers do not expect us to do lot to lot, like strictly speaking. So what usually is done in the labs is usually verifying continuity of performances, like Kevin has said. So I can only reiterate what you have said, that you want to check continuity of performance across different EQA rounds, and that's or when EQA materials lot changes. So this one is maybe will help ensure that no step changes or biases is introduced. So you do that before. If a lot has changed, and we have said that most of these EQAs, most of these third parties take so long to change a lot. But once it's changing, so think of it as EQA performance trend monitoring across different cycles and different lots. So that is what usually is done. So there is no like any mandatory time that you should do, only maybe when you're changing a lot. Or when you receive an EQA material lot that was not the same, or when maybe you're changing a method or an analyzer, you can be able even to use and check what you're performing against what should be expected. Maybe that is what I can say.
Okay. Bosley Motaroki, please make it on presentation mode. That was done. Maina Gadhanga, hello, could you please send me that catalog through my email? We'll send you that. Rahab, hi. Can one use QC material for hematology from different companies to calibrate FBC machine? E.g., Huma 3TS, you calibrate with QC material for Mindray machine.
That's really cool.
So in terms of calibration, there are different ways to calibrate a machine. You can use a patient sample that is from with values from a machine that you trust. You can use a calibrator, or you can use a QC. So if you decide to use a QC, I would advise that you use a QC with values for that machine. And most oftenly, it's always the normal QC that is used for calibration. If you decide to use a QC from another machine, the values won't be comparable. That's why you realize that the values for Mindray and the values for Huma count are always different. So with that, your calibration would fail. So I won't advise that you calibrate your hematology machine with QC from a different hematology machine. Okay. Sarati, based on peer group EQA data values, can EQA samples be used as third-party controls? Wow. So EQA samples, Catherine, what do you think before I respond on this?
I didn't hear the question kindly.
Based on EQA peer group, EQA data values, can EQA samples be used as third-party controls?
Controls. Wow. How much of EQA will you have? Because usually, because you see that party controls, if you're running them as internal, you remember we mentioned about us doing this daily or in a frequency that is agreeable to our risk-based matrices. EQA as a third party can only be used in specific periods. Like for example, on a monthly basis, you can decide that you're going to do a peer group comparison amongst labs, your peers, the people who are using the same machines as you, there's people who are using the same method as you, but this can only be done in certain periods. Usually EQA are not done daily. They are done in periodically, annually, not annually, sorry, monthly, quarterly, after every 3 months, after every 4 months, after even half by annually, all that. So how much material of EQA will you have to be able to achieve to run it every day is going to be very costly.
Yeah, so we wouldn't advise that you use EQA samples as a third-party control. So just use the independent third-party controls. That is whereby you'll be able to see the peer data and see how you analyze the compares against other analyzers. Question 2, can one manufacturer QC samples for a different equipment be used for another equipment as third-party controls? No. One manufacturer QC samples would come with its own values, and another manufacturer also would come with its own assayed values. So you can't use one manufacturer QC on another unless you have got assays for that specific equipment. There's this notion of, but the QCs are still passing the expired. Can this be part of the manufacturer-specific biasm? Please address.
Of course.
Okay, kindly address that.
Oh, no. Okay, sorry. I was saying, of course, it's been optimized to do that. It's been optimized to do that because this is manufacturers. If you can imagine you producing your own analyzer, reagents, calibration, then your QCs fail. They're not supposed to fail. They've been optimized to perform nicely, to behave nicely around your platforms. So it's going to pass.
Talk about manufacturer generated mean and calculated or machine generated mean.
So manufacturer is what comes with the insert. Manufacturer mean. That's what comes with the insert. After several runs, they have developed their own data. They have their own SD. They have their own target and the ranges. So they expect you to input that as a guidance for you to be able to now develop an LJ that you will use to. So after the first run of, for example, a lot that you have just loaded, after the first run, you want to check how it is. Is it at the target? Is it somewhere away from the target? How far away? Then if maybe it's a fail or it's a bias, positive or negative, you check the second run. Usually it's done immediately after that one. So you check, and if there is consistency or there is a trend, so you want to give it time. If it's passing, you want to give it, or it's on the same side. CRT, moja is negative, the other one is positive. So once you, for example, you get a positive bias, it's up there above the target, the second run. So you give it 20 runs, not at once, 20 days. You're going to run that QC for 20 days. Then the machine, nowadays the machines that are coming are developing their own mean. Usually it's called the lab mean, the laboratory generated mean. So that is what you usually adapt. You reconfigure as, for example, some platforms have the option of even having the manufacturer left, then they give you an extension of you putting your own lab means. So from that point henceforth, you will be using the ranges that you yourself in that lab developed or generated.
Okay. Do we have third-party QCs for qualitative tests? Yes, we do have. We have third-party controls for qualitative urine analysis. We have got third-party controls for rapid strips. Maybe you want just to confirm if a positive is a true positive, a negative is a true negative. We have got third-party controls for that. And then which one picks the systemic errors best, manufacturers or third-party QCs? Like we mentioned previously, manufacturer QCs probably would be biased just to ensure optimal performance of their reagents. So we would advise that you use third-party QCs to just identify or pick up the systemic errors real time.
For sure, we say that the third-party QCs are better for systematic error detections because it's independent to the analyzer and the reagent manufacturer. So it's more likely to reveal biases and calibration drifts and even lot-to-lot reagents effects, because when you load, you will notice maybe a shift, and when you check, you will notice that there's a new lot that has just been loaded. So it's less prone to system checking itself. So that party usually is stronger at detecting the common mode failures. And this shift maybe can be calibration drifts. You remember that the systematic ones that we're talking about, the calibration drifts, the reagent lot-to-lot biases, the method biases, the subtle positives, and the negative shifts. Yeah. So usually the manufacturer is weaker.
Okay. Samuel Asendi, you back? You said that means third-party QCs shouldn't be used in method comparison.
For sure, before... Okay, sorry.
Okay, just proceed.
Yeah, I feel like that is for sure, because that party QC, because that party QCs cannot, or rather, how can I put it? Wow. Because method comparison cannot be done using, we cannot compare, or rather, comparisons cannot be done using that party QCs. Comparison is usually done using patient samples. Why? Patient samples are usually truly commutable across platforms. They QC, that party QCs, you say they are commutable, but they may not be commutable, especially remember for the immunoassays, like we said. So usually, method comparison, I think it's safe to use patient samples.
Okay. What's the confidence level in percentage assurance for 1SD, 2SD, and 3SD?
Wow, this is a whole new discussion of setting the rules. Hey,
Statistically, 3SD is 99%,
yeah,
2SD is 95%, and 1SD is 99%, 2SD is 95%, and then
no,
3SD is 65%.
I'm thinking it's the other way, but I'm not sure.
One is
Anyways,
the one is this is stronger, so it's 99%.
oh, okay.
Yes. So Sarati, I think it's that way. The confidence levels, 1SD gives you a stronger confidence interval, 2SD gives you a medium confidence interval, and 3SD
Oh,
gives you
yeah,
a lower confidence
true.
interval.
Yeah,
Okay.
so at 3, it's quite huge.
Yes. So
Yeah,
if
so
you want to,
so everything will be falling within.
yes.
Okay.
Vincent Omondi, what is the best practice when QC parameters do not meet the manufacturer stipulated means? Do you generate internal QC ranges? How long will it take to get the average 20 readings considering other factors? So, Vincent, what you do when you get a third-party QC, you always do your own internal QC runs. Probably, like I mentioned, you can do it 5 times. That is 5 days prior to the previous lot expiring. So once you get your own mean from the 5 runs and your own SD, you can calculate your coefficient of variation. And I think for most labs, the acceptable CV is always less than 10 for that new QC lot. So if your CV from those 5 runs is less than 10, you can accept that QC and say it's okay. So the best practice is to just run your QC at least 5 times prior. But if your lab has got resources, you can do it 20 times, like you mentioned prior, so that you can get your own lab developed mean and your own lab developed SD. Is it that for you, Catherine?
Yeah, usually that is when you're told don't wait until the other one is out or you have run out of it. You start preparing early. So one is used to check the other one. One is
Yes.
used to check the other one. You cannot change everything that now QC zimeisha and the lot has never been loaded. It's a new one, and now it's when you have so many variables, so many risks so that's why, like Kevin has advised, you do it prior. You plan mapema.
Okay.
Yeah.
Athman Ramadan, are there third-party calibrators? We don't have third-party calibrators, but we have what we call calibration verification materials. So we give you samples, and then you run them independently, and then we have a software that does calibration verification. So we'll give you statistics to that. Okay. And then Lincoln, kindly tell us commonly available chemistry QCs. Kindly tell us commonly available chemistry QCs other than human and Cerodos. There are 1,001 chemistry QCs, so just depends on the assays. So if your machine is appearing in the assayed insert, you're good to go. Omari, short answer yes, EKA material can be used as that party, only that it will be expensive. Most EQA has got short stability issues, and yes, the fact that it's occasionally done monthly, quarterly, that's already keeps seeing, but then not ideal. Perfect. Amazing presentation indeed, very informative. Does the speaker provide external quality guidance to labs, and at how much? So Washington, we also have got EQA services. We'll be able to reach to you through that email. We've just picked your email, and we'll be able to just reach out to you and see how we can support you in terms of external quality assurance. Victor Goro, 20 days wait to get a mean is long. Is there an ongoing study stroke research to reduce the time, maybe to a week, or it can be spread out for a week? So, Victor, like I mentioned, you can decide to use 5 days before the expiry of the previous lot, or if your lab has got resources, you can go the 20 days way. But both the two are acceptable, provided you get your own lab developed mean, your own lab developed SD. Sindio, Catherine?
why we increase the days is to be able to catch the other variables.
Yes.
The other variables away from you remember we had so many controls. You remember we had even the process controls. So we are trying to spread it. For example, you're spreading it to be able to catch any most of these QCs, remember, are made elsewhere. For example, they are made, for example, in UK or in Europe or in US, or because once they get here, there are so many variables that are affecting them. So we spread it along the 20 runs so we can be able to catch any other variables as you're giving ourselves time to get to measurement uncertainties.
Okay. And then Mary has just given us one SD is 99.5, two SD is 95, and three SD is 67.5. That is okay. Vincent Omondi, good presentation. Some equipment of same platform tend to perform differently depending on the source and type of IQC. What's the best practice when you have varied outcome from the manufacturer IQC and third-party IQC? Which results will override the other and why? So like we mentioned, Vincent, the best practice is to develop your own internal lab min from those individual runs. So that will override all the other variables. So if you just run the samples 20 times, you develop your own lab min and your own lab SD. That will be able to guide you to use as your own min and SD. Is it that, Catherine?
Yeah, and also we should just not just let it override, but you should also try to treat the discrepancy as a signal that needs investigation. So you want to know that that party QC often carries more weight by detecting the like we mentioned, the systematic biases. But the patient samples results should be held until the cause has been. You want to know why is there a variance, root cause, and then sort it immediately. So the best practice when using manufacturer QC and that party and they disagree is you're usually told to check the non-conforming conditions. The best practice is do not release patient results until it is resolved, because even the manufacturer QC is even if it's in control, that party QC failure suggests a possible systematic drift. So I think we are in agreement, Cindy.
Yes.
Yeah.
Yeah, so Gordon has requested for the presentation. We'll share the presentation in our WhatsApp groups, and then you'll be able to review. And then we'll be able to upload the CPD points later on automatically. So if you registered, ensure that all your details are correctly captured so that you don't miss the points. We'll give you 3 points for this CME. And also, if you require any third-party controls, we'll be able to support you as Keton. We have got controls for hematology, controls for chemistry, controls for immunoassays, infectious diseases, urine analysis, end-to-end lab. So if you need any type of third-party controls, just reach out and we'll be able to support you. Otherwise, we thank you all for joining us and enjoy the rest of your Thursday and have a pleasant day ahead. Thank you.
Thank you.
Okay.